Thank you for joining Manufacturing in Motion with Austin Roden. I'm your host and engineer from Industrial Control. This is a video of Banner's SC10 with InSeries Diagnostics showing how to use the RFID gate switches. And with that, I'll pass it over to Roger Birnbaum.
So looking at the SC10 just directly, again, it's very intuitive. So it uses the exact same software as the XS26 does. Looks identical. You just have to choose when you power up the software. Am I doing a XS26 or a 10? So it knows what terminals and that type of stuff to assign. Has the same communication protocols. The module has two outputs, output 1 and output 2, and each output has 3 safety normally open contacts. It has 10 inputs, so it has 10 input terminals down here, 4 of which are convertible. And these outputs are fully redundant. So inside this module, there are there are 4 relays. And each output, 13, 14, that's one output, can do 6 amps. So you can actually switch a lot of current. I always caution people when they're asking, well, what's the maximum current? Well, remember, when you burn up the relays in this module, you have to replace the brains of the module also. So if you're switching, some higher currents, yes, I can handle it. But from a long-term cost standpoint, it's probably best to have some contactors out there keeping the current across these relays at a reasonable level so that they can last a very long time. So again, we have the fast swap out process or fast programming process in the SC10. Just put this little baby in here, it automatically load it up and get you going if the unit's at factory defaults. We have something we call automatic terminal optimization. When I added this first device, this eStop, it's going to be using up my IO1, my IO2. When I add the second door, we're using the contacts, it's going to use IO3 and IO4. Well, that's my 4 IO terminals, which can be used multiple times, but when you're just starting, I'm only using them once because each terminal only accepts 1 wire. But if I add a third door, it's going to automatically combine my IO terminals into IO1 and 2, which I could use 3 times, and then it'll also show this external terminal block. So to hook this up, obviously into IO1, I can only bring 1 wire. Well, you need a little DIN rail external terminal block to connect the 3 inputs, bring that 1 wire out of the that terminal block into the IO mod or into the SC10 into IO1. So we'll automatically switch over and show the IO terminals going into these blocks, showing these external terminal blocks for you. So we call that automatic terminal optimization. So now we're getting into the fact that we have the InSeries Diagnostics, or we like to call just ISD, inside some RFID switches, and we just recently added it inside the SC10. But before we added it to the SC10, that ISD information could be pulled out of the SIRF switches and then converted to an IO link signal and sent to your PLC that way. So you'd have a nice chain of RFID switches going in, being powered up, going to a diagnostics module that then went to a safety evaluation device like the SC10. But that diagnostics module is taking the information that's embedded on the outputs of these RFID switches. It's stripping that information off, passing the safety signal on, and then converting that signal from the proprietary communication path that we have into an IO link signal being sent out to your system, which then has to go to your PLC. So you could get the information, all status information, tell you which door is open and all those types of things. So it was easy to obtain what you needed, but a lot of wiring, a lot of extra parts, adds more cost. Well, now that we've added this feature to the SC10, obviously I did not update this slide since it still says target launch Q1 of 2020, and we did meet that goal, so that's good. So it has already been launched. So you have the same system, but you notice there's no diagnostics module here. It's just going directly into the controller, directly out over the various communication protocols, depending on what we have or what's needed in that system. So it needs a lot less parts, very easy to set up, very simple to do. Much cleaner system and less expensive systems, to get the same information out. So for the big highlights of it is each one of those chains of ISD devices can be 32 devices. So I can get up to 64 devices connected to the ISD inputs, and that's only 4 of the terminals. So you still have other terminals, or you could connect a light curtain or something else in that manner. And it's very easy to set up in the software, which of course we'll show you when we get to the software. And here's kind of what you can see when you've attached these ISD chains. As of today, the only thing that's available with the InSeries Diagnostics information is the SIRF switches. But you can see I have an e-stop showing over here in the system. We will be releasing a e-stop, some of our lighted e-stop series with the ISD information, and hopefully this summer. It all depends on what the coronavirus does with the speed of the approval agencies of evaluating and approving our e-stop circuitry. But one thing that we have with the software, which I won't be able to show you today, is something we call live mode. This is a picture of the ISD tab in live mode. This top series is showing the 2 sensors we have on the demo are in place. So the actuators are in place, the sensors are on, so that input channel is on. The e-stop's in the run state, so that input channel is on. Well, I've removed one of the actuators, so that actuator is no longer being detected. So sensor 2 went to the off state, turning off that ISD channel, and I hit the e-stop, turning off that ISD channel. So from a top level, I can easily see, the channel status is on or off, and I can also see the individual door status being on or off. And then I can even delve into it in much more detail. That channel 2, or that device 2, I should say, of chain 1 was off, so I clicked on it to highlight it, and I can get this advanced information. It shows me the outputs are off, the inputs are on, so device 1 is still on, but the actuators are removed, so the outputs went off. This is no local reset is required. Everything's running fine. There's no errors. What type of device is it? This one's a door switch, so it says door switch. The e-stop would stay e-stop. And it also has what was the expected code. 1, 2, 3, 4 means that this is a low coded device and there is no expected code. I'll work with any actuator. If this was a top device, the higher unique coded ones, there'd be an actual code in here, 9x32 or whatever, whatever code is the actuator's taught. If I had an actuator present, any coding, I'm still going to read that actuator presence. So what actuator is being read is fed into the system and can be pulled out via the Ethernet. So if you have a rotating table and you want to know if it's at position, 1, 2, 3, or 4 is here at the welding station, you could put RFID actuators at each one of the positions on that, and that could be read, fed to the PLC, so I know which position it is. So it's just basically comes to you as part of your safety system with no extra parts. How many teach-ins remaining? If I had a lower high switch that could still be taught more, it would tell me. I can get the supply voltage. Why do I care about that? Well, that gets into how long my system is, how well it can maintain the voltage at the 24 volts. It has to stay up in spec above the 19.2 volts. I can get the internal temperature. No idea what you would do with that, but I can. I can actually get the distance the actuator is away from the sensor. It's been removed from the sensor, so it's greater than 18 millimeters. There's actually a range from 13 to 15. If you get that, will trigger a range warning count. That'll trigger this range warning count telling you, hey, you got some margin. I can see it, but it's kind of marginal. So your door is getting out of alignment. You might need to tweak that in before it's completely out of alignment and won't close. So a lot of information that can be pulled from each individual sensor. So that's the advantage of the ISD is this is the ISD information. This is the information you can get from each sensor. And there's also some cyclical data that you get from each chain that's automatically sent over that basically talks about the health of that chain. If it's on, if it's on, if it's off, if the terminator is missing, if you had the wrong order of devices, the wrong number of devices, that information is there automatically because that sends out alerts saying, hey, I'm off because of this. It's like I've already opened it up with the SC10. I assume you can see it again, right, Austin?
Yes, sir.
Okay. So if I'm starting with the device, obviously this SC is just saved to control and not expandable, so I can't add any modules, but I can add input. So if I want to add an input to the system, I can add an e-stop, I can add doors, those types of things, or I can add an InSeries Diagnostics chain of devices. So I can select that. It's going to automatically populate in one of our two chain input positions, 3 and 4 or 5 and 6. I can select how many devices I want to add. So I can add a system of 5 devices. I can select door switch, or when we actually come out with the e-stop and other devices, you'll be able to add other devices on here, but at the present time, I only have door switches. I can actually name in each one of these devices instead of leaving it as device. So you can go down and name each one if you so desire. So I can add other inputs. I could add we're at a safety mat. Nah. Add an e-stop, and I'll add another device here, another e-stop. So if we go to the wiring diagram, you notice that the second e-stop has consumed my IN3 and my IN4. Well, that will limit me now, or if I click on another input, I can't add another ISD devices because I need ISD 3 and 4. So what we can do is you can actually go into the second e-stop and change it. So instead of coming from the IO3, I can make it IO1, which freed up showing that device. Where's my IO3? There we go. You have to get really tricky. And you actually have to disable the automatic terminal optimization to do it. So now I can get, so now if I change these to IO1 and 2, I can actually do 3 and 4. So now if I go back and add another device, why didn't it go? Oh, because I changed the wrong one. That's why. When your presenter's an idiot, it doesn't work well. So now I've freed up 3 and 4. I can add another chain of devices. Again, I can name them, that type of stuff, so I can add them in there. Now I want to make these devices. And you notice that when I added the ISD chain, it told me, hey, this configuration requires a base module that's FID2 or higher. So if you add something that's needed, that's had some change from the very basic that we started with, we tell you what is needed. Now, it's not a huge deal because once we started shipping FID2s, we have no more FID1s. That's all we will be shipping is FID2. Once we go to FID3, we'll only be shipping FID3s. Once we start shipping the new things, we do not go back because we've managed to keep them backward compatible. If you have an FID1 device, this software will talk to it just fine, unless you added something that requires an FID2. So if I want all these devices to be on to turn my output on, I can add an AND block. How many input terminals do I want on the AND block? I can add up to 5. I only need 4 for this case. And it's just as simple as clicking and dragging. I can add it over to my output. You see my wiring diagram shows me how it's all wired up. My ladder logic shows me my pretty simple ladder logic. My configuration summary, including down here on my response times. I even have my ISD tab, which shows me the order of the devices that I've assigned it. And we show the terminating plug because device 1 is out there by the terminating plug. The highest number in the chain, in this case 5, is by the controller. And that's so you can print it out, give it to the person. This is how you hook it up. Because once we release the e-stop modules, you'll be able to, I could have door, e-stop, door, e-stop, door. Well, if that's how I said it was supposed to be, and you wired it up, e-stop, door, door, e-stop, door, hey, that doesn't match. I'm actually going to give you an error message saying you have the wrong order devices in the ISD chain. So that's why it's critical on how you want to wire it up. Plus, if you name things individually, you don't really want it wired up. Door 2, door 3, door 1, door 3, door 2. You want it 1, 2, 3, 4. So you want it to match the order. If I have the system hooked up, all wired up, you notice that the double gear shift here turned on, which is a simulation mode. So I can actually go in and simulate what I created. This is just a simulation. It's not a substitute for commissioning checkout. It kind of gives me the ability to verify my software. Did I do it right? So at the present second, the machine is not on. That's why everything's off. My timer's not running. Now I powered the machine on. So I close my doors, reset my 2 e-stops, close my other door, I turn my outputs on. If somebody opens one of the ISD devices, turns it off. You can see what's happening in your equipment view, your functional view, your wiring diagram by terminal. So here is my simulation. If it turns on and off, I can see what my terminals should be doing. My simulation mode tab. And in my ISD, you don't see anything on there during simulation because opening any of the doors is going to turn the whole string off. So it doesn't really need to be simulated that much, doesn't show much. But if you get some pretty complicated software, the simulation mode can be very useful to show different things. So that's pretty much what the software can do and what it has. Any questions you have, Austin?
Yeah, so the first question, what are some common gotchas that somebody might run into when setting up specifically the ISDs with a system?
Gotchas? I don't really know many gotchas with it. With the RFID switches, you got some nice tolerance on the doors. You just need to make sure you have the spacing. They can't be any closer than 100 millimeters to each other, so they don't get any interaction between them. The biggest thing is that you have to watch your voltage. You have to make sure that, if you've got I have only 5 doors here, but if I have a mile of wire between each one, I might run into enough losses that my voltage down here at, number 1 drops below that 19.5 volts, which could cause some issues. Other than that, there's really not that many big issues with it. The door switches isn't a big deal. The e-stops being the lighted ones, there is some current draw for each light. I mean, powering each light up does suck down some current, so you could run into having enough current that you are getting a lot of losses, so you might need to add extra power multiple places down the string if you have a lot of units in one long chain. So that's about the only things, really.
Seems pretty straightforward.
Yep.
got another question. The part where you were talking about 4-channel safety, you can detect ground faults, power faults, etc. Are you able to see these specific faults over Ethernet IP to the PLC?
You are, so if I have this e-stop on here and, you know, IO1 is coming out, come back into IO3, so IO3 is checking for these test pulses. If those pulses are seen over here in IO4, I obviously have a short between the two channels. You know, it's going to turn this off and it's going to fault that input. And it'll fault that input with a very specific fault code that's in the controller. You know, I don't know the specific number for that one, but let's say it's a 2.8. You can over Ethernet get that data. Not many people do, because what you get is a 2.8. You know, you won't get with the explanation of what it is, so you'd still have to look in the manual to see what a 2.8 is, or embed into your PLC or your HMI what all these numbers translate into. I've personally not talked to all but 2 people that have ever done that, and one was a sales guy, and the other guy just thought it was cool. Yeah, so most of the time, what people want is going to be, so if I go to my Ethernet tab, which I did not do, which I was supposed to do, so I can go in here, I have my configurations all set up. Let's see here, do I want to set it up yet? I'm going to get rid of one e-stop. No, I don't need to do that. I don't need to do that. I can do this. So I'm going to add a reset to this output. So I'm adding a reset node. So this will be manual reset. I don't have any terminals left, so I can't add a physical reset. But I can add one of those virtual resets. So I'm going to add a virtual manual reset, which I'm also, anytime I add a reset to the system, I always recommend, I've been trying to get engineering to set it as default, but they won't. I always click the system reset. And the reason to do that is when I load this configuration into the controller, I have 2 ways of finishing the configuration. One way is cycling power. So it's finishing the process of taking it from GUI language into machine language. So I can cycle power to the unit. So when you're playing with it on your desk, cycling power is no big deal. But when it's inside the machine, cycling power is kind of a pain. The other way is giving it a system reset. And it can even be a virtual system reset. So instead of having to cycle power, I can just send it a reset signal that's going to finish the configuration process. So I don't have to cycle power. So you notice when I added this virtual reset, it told me I need an actuation code. Well, the actuation code is assigned up here under network settings. Same place you, don't hit it too many times. Same place you put in the IP address, your gate, and all those different things. It's a 5-digit code that you can make anything you want. So you can make any number that you want to do. If I was actually connected to a controller, my IP address and that I send from this screen right here. So I'd send it into the controller from right here to put my actuation code in the controller. So now I have everything set. I can hit this auto configure. So we'll give you all the status outputs we think you might want, you know, systems lockout, track input, track fault, track each output, track each input. And you'll notice I have these different flags over here. Here's my on-off flags. Then I also have a fault flag. So if that e-stop I said was shorted to, you know, together, is shorted together, this is going to go low because it's off. This is going to go high because it's faulted. Most of people, that's all they care. Okay, I have a faulted e-stop. The maintenance guy knows it's a faulted e-stop. He's going to go look at it. You know, could I get the fact it's a 2.8 fault? Yes, I could get that with a explicit message. Hey, you know, give me the fault code 1, and it'll come back with the, you know, the ASCII format saying, you know, you convert it out as a 2.8. I mean, this guy's still going to have to go find the manual, look in the manual to see what a 2.8 is. So very few go to that detail. You can, but very few people do. The one thing you do need to be careful with is these check boxes up here. Right now, we have ISD, so I can tell you that's going to be a 103 instance. So my ESOP that was shorted is 05, but my fault flag is actually going to be here at 16.5. So be cognizant of what instance you're actually looking at. Is it 100, 101, or 103? Because I didn't realize this myself till not long ago when we were dealing with somebody. Well, I don't know why 4.5 isn't changing, because he was using 103 and it's not 4.5, it's 16.5. The reason there's a difference is the fact that we originally had 64 virtual status outputs. That was here. These fault flags then came next. Well, now we have a lot more, 256, so we just copied those first 64 over. So that's why they're way out here at 16. So it's just because we added some and we made it backwards compatible. So that messed things up instead of being super easy and straightforward. I can change which language I want to be looking at. It instantly changes the screen. I don't need to repopulate it at all. It's once I added one, it's there. I can also look at my virtual non-safety inputs. Let's go back to Ethernet IP. So I can see I have here's my, my 103. This is my sending it out. So I'm going to send off to my actuator. When I do the reset from the PLC, that's going to be this instance 113 is going to send bit 80 is going to go to a 1. I'm going to send the actuation code in binary to 10, to word 10. Once I get it, I'm going to send back from word 32 and word 34 for the actuation code. So this will show you what you're doing on the virtual input side. One's technically an output, but who's counting? If you also noticed, when I was in Modbus, there's nothing over here. But when I'm in Ethernet IP or Profinet, we have this export button. You've already created some various names and things for all your devices, including even the ISD devices. Well, instead of having to retype those in the PLC, you can actually hit this export button. I need to know what the name of the controller is in the PLC. I want my virtual reset cancel delay information plus the ISD, because I have ISD in this device, and then I can hit the export button and it's going to create a CSV file that I can either directly import into the my PLC, or I can play with it in Excel if I want to. It's only in those two languages because at this time that's only when we know that you can actually easily set a file up to pull into the PLC. The other ones we haven't figured those out yet. So if you're a great expert and know how it's done, please let us know. We'll gladly add it. So that's a nice feature, especially as the size of your configurations grow. It saves a lot of time of entering and creating names. Any other questions?
Great. Would you be able to open up that CSV file real quick?
I can. I just have to change my sharing. Opening, it's the easy part.
Now, while you get that uploaded to that new screen there, what seems to be really cool is we can pretty much now reset the whole safety controller via Ethernet IP, which really puts us in line with a lot of our competitors. And with
Well,
that function.
especially with the proliferation of HMIs, where all the buttons they're no longer buttons, they're icons on the screen. I mean, you always could do it, but you had to, hardwire in a line from the HMI to the controller, which is like, well, I'm already talking to it over Ethernet. Why can't I do it that way? So it's just makes a lot of sense having it. So that, this obviously wasn't the one since I had canceled, but this is one I'd created previously in a different configuration. You can see I have my two outputs, my various inputs, and then it gets into the ISD information that can be, shown in there. The ISD information does not, I repeat, does not use any of the 256 virtual status outputs. It's other information. It's extra information or more information. You'd still have 256 other status outputs you could make. I have no idea how you'd ever use that many, but hey, go for it.
So on the ISD outputs here, is this the information that when we upload it into our PLC, we can make it say on our HMI, door 2 is open, door 2 has the wrong actuator, door 3 has a power issue?
Yes, so you would have the top information right here would tell you your strings on or off. And then I'm getting into my, door device count and those, and then I can get down to more of the individual information is further down in here. You request the data and it comes back so I know the whole string is off. Here's my door status 1 through 16, 17 through 32. So, okay, which one of them is off? And then I can say, okay, door 18 is off. And I can ask information about door 18, and here's all that information about door 18, why it's off. So it is kind of a multi-step process, but most of the time, excuse me, most of the time when you're running, all you care about is the whole chain on or off. Yeah, so most of the time you aren't asking about anything else. But once it turns
really
off, then you can
powerful.
go in more information. Yeah, you can get a lot of really great information off of it. And a lot of different usages. I mean, the customer is the one that said, suggested that, well, we have a machine that we use a lot of different tools in depending on the job. Well, they can embed a actuator in each one of those tools, read that actuator when it's in there, check it against the PLC, what says what actuator should be there for that job to make sure it's right before they start running it. It's like, oh, wow, yeah, that's a great idea.